Hello everyone. Today we are going to go over the answers for the Module 14 review. And let's take a look at number 1. For the data set to be modeled by an exponential function, which relationship is necessary between the successive values of f of x for equally spaced values of x? And so let's take a look at the answer choices. The choice A says the first differences are approximately equal. B says the second difference is approximately equal. And the third one says the ratios are approximately equal. So the answer choice should be C when you have a list of data that the two ratios, like the successive rate. So if you have like 1, 2, 4, 8, 16, for example. So if you find the ratio, as you can see here, everything is consistent. Every ratio is times 2. So the successive ratios are approximately equal. So that's or equal. So that's the answer for number 1. Number 2, which regression equation best fits the data shown in the table? So if you actually look at the ratios, the first one is times 4. Second one, 22 divided by 4 is about 5.5. And then the third one is 124 divided by 22, which is 5.64. And if you want to find the approximate ratio, you would average it out. So you would add 4 plus 5.5 plus 5.64 divided by 3, and it should be approximately 5. So the base B is 5. So out of these three equations, only B has a base 5. So that would be the actual answer. Number 3 to 4, use the table below, which shows data that can be modeled by an exponential function. So here's the exponential function equation, general equation. And so once again, we're looking at this table here. And if you're trying to find the ratio, the first ratio is 8 divided by 5, which gives you exactly 1.6. Second one is about 1.625. And then the third one, 21 divided by 13, is about 1.615. So find the value of b by calculating the successive ratios of the function values and finding their average. So b is going to be 1.6 plus 1.625 plus 1.615 divided by 3, and you should have base approximately 1.6. And what is the best value for A in the model? So model A, the one that has the initial value, is the one with the x value of 0. So A is actually equal to 5. Let's move on to number 5. Maria found the function f of x equals 1.06 16 times 0.9 to the x to model the data below in this table. Make a scatter plot of the data and graph Maria's model on the coordinate grid below. How well does the model fit the data? So first thing you should do is go into Desmos, everyone. If you haven't done so, go into Desmos and enter the x column as x1. Open up the table, and then the f of y value will be y1. So enter those two data. And then when you're finished, you will be able to see the scatter plot. And then I want you to enter Maria's function and into the function, and then you will go ahead and see how well Maria's data fits. So I've already previously done that, so make sure you guys pause the video for a second and then make sure you guys do that. So here is my model for the table with the points and showing the scatter plot, the 5 points. And then you can see that Maria's equation is right there in the second line. And that black line is the actual graph for Maria's model. And as you can see, the model that Maria has fits exactly on the dotted line. So that's a perfect fit. So the answer to number 5 is how well does the model fits the data, and it says it should be model. The model fits very well to the data. Okay, so that's number 5. And you can go ahead and transfer the graph onto the space provided. So this is a decay, and you should like put the dots in and then draw the actual model that Maria has. Okay, number 6, you can find an approximate exponential model of the data graph below by substituting the coordinates of the point 0, 30, which is this point right here, the first point, and the other point into the function. Which point is least likely to help you find an exponential model that fits the data well? So if you follow the model and you start with the points and you start the exponential model, you will be able to connect most of the points here, and you can see with your very own eyes that the point that does not fit well with the line or the curve is this point right here, which is 3, 5. So that would be the most appropriate point, and that point is going to fit the curve like the least. So that's the answer, C. Let's take a look at number 7. The price of a certain company memory chip from 2010 to 2014 is shown below in the table. Enter the data into the list of your graphing calculator, and then use the exponential regression feature to find the constants A and B, and then write the exponential form for the equation and find as a function for the year 2010. So here's the list of data. You should go ahead and once again, open up your decimals and enter x1 and y1 into the table, and then don't forget to pause this and try it before you look at the answer. So here is what I have. This is the table, and then I've already asked the calculator to calculate the exponential function, and you should be able to see that A is 157 about, and B is about 0.778. So that's the equation, and it looks like it fits the data well. So we're going to write down A, the value is approximately 157. B is approximately 0.0778, and the function is of f of x, put it together, 157 times 0.778. And one thing I want to point out in the graph is that because the data starts with 0 for x, don't forget that when you are graphing, you need to check that log mode box for the equation. So then you will be able to avoid getting into undefined values. So let's go ahead and move on to number 8. Which type of model would be least appropriate for the data shown in a scatter plot? So here we have a curve. It's asking which one is least appropriate. So if you actually look at this curve, the dotted line, the dot scatter plot, it actually should look like it should follow somewhat of either an exponential, or this could even qualify for quadratic. So the least likely is going to be linear in this case because it does not really fit a line. So the least likely is linear. And that's the answer. Number 9, using data from 2010 to 2014, a sales manager finds an exponential function to model his company's sales. He then predicts company's sales will grow from 2 million in 2010 to 1,673.4 million in 2030. Is this prediction reasonable? So if we are just only using two years of data to assume, or 4 years of data to assume that it's going to be the business model for the next 30 years, I think that's or 20 years, that's actually shaky. So I think the answer should be no, because the model that is based on 2 years or 4 years of data should not be used, because this pattern in the real world may very well not likely to continue. So that's not a very stable set of data. So that's number 9. Number 10, here we have a scatter plot again. Choose the appropriate model and find its equation using a graphing calculator. So if you actually take a look at this set of dotted lines, pretty much it follows, I think the best model to fit it should be a linear regression. So if you actually enter that into the graphing calculator, you should be, so linear is the best model. And the equation, let's go ahead and look for that. So make sure you pause it and enter x1 and y1 into your decimals and generate the linear line before you actually look at the answer. So here we have the set of data, and I'm showing you my answer for generating the linear line, and it looks like it fits very well with the set of data. So my equation is negative 3.03 plus 10.37x. Or you can write it as y equals mx plus b form, so that would be 10.37x minus 3.04. So either way is fine, as long as you have it in linear. So that's the answer. And then number 11, which scatter plot should be modeled or could be modeled by a quadratic function? So A so far looks like it would fit the quadratic function. B, it does not look like it's going to follow through. And then C is all over the place. So the best answer in this case should be A, that it follows the quadratic function model. And that is the end of the review for Module 14. Have a great day.